Mid-August 2026 saw global digital infrastructure hit by a synchronized wave of cyber attacks. In a sweeping transnational operation, Europol dismantled a massive banking fraud ring, arresting the key architects behind a €30 million heist. At the exact same time, data, and simultaneously, a maximum severity vulnerability in SAP Commerce Cloud, scoring a perfect 10 out of 10, was actively weaponized in the wild. These three breaches, occurring within the same 72-hour window, expose a systemic vulnerability that traditional security was never built to handle. For decades, network security relied on a castle and moat model. You build a strong perimeter to keep threats outside. But that model fails if an adversary is already operating inside. The castle walls provide no defense for the keep. By performing a forensic autopsy on these three specific oddest breaches, we can see why the strategy of building taller digital walls is now a fatal one. The €30 million banking heist reveals the first crack in the wall. The cybercriminals didn't actually launch a direct assault on the 20 commercial banks they stole from. Instead, they infiltrated a trusted third-party fintech vendor. As this document details, the attackers maintained undetected access within that provider's infrastructure for several months, effectively bypassing the bank's direct perimeters. They used fileless malware to stay hidden. While traditional antivirus scans files on a hard drive, this code runs straight into the active memory, or RAM, leaving almost no forensic trace on the physical disk. From that stealthy position, the attackers forged authentication tokens to automate weekend fund transfers directly to decentralized cryptocurrency wallets. Because the banks inherently trusted their software vendor, they left a backdoor open that neutralized their strongest primary defenses. We see a similar bypass in the energy sector. The Clop ransomware syndicate compromised Shell by exploiting vulnerabilities in the company's secure file transfer protocol. The attackers hijacked the very pipelines designed to safely move corporate data in and out of the network, using the company's own infrastructure to pierce the perimeter. Once inside, they executed a double extortion campaign, locking up the internal systems while simultaneously siphoning out terabytes of confidential geological and commercial data to hold for ransom. Legacy internal networks offer zero friction. Once that exterior shell is pierced, attackers are free to move laterally and extract everything of value. Then there is the SAP Commerce Cloud vulnerability. Thousands of global enterprise supply chains run on this platform. A single flaw creates the potential for an unauthorized override of entire commerce ecosystems. A CVSS 10.0 unauthenticated remote code execution is the worst-case scenario. As the advisory outlines, it grants an attacker complete root-level administrative control over a server without requiring a single password or login credential. This risk extends to the very edge of the network. While enterprise portals are being breached, Evo 1bot hijacks Linux edge rubbers, and covert miners exploit employee MacBooks. The attack surface now encompasses every unpatched portal, every edge gateway, and every employee laptop connected to the web. A single flaw unites all three of these breaches: the assumption that any user or device operating inside the network is safe. Securing modern infrastructure requires a shift towards zero-trust architecture, a framework built for a world where no connection is considered safe by default. Zero trust operates under the permanent assumption that the adversary has already gained a foothold. Instead of one big wall, you place individual security nodes around every data point, requiring active verification for every single connection. Surviving the brutal realities of the 2026 threat landscape requires the complete replacement of implicit trust with continuous, engineered paranoia. This transition begins with the principle of least privilege, replacing broad VPNs with strict permissions to stop lateral movement. Next, real-time behavioral telemetry counters fileless malware by actively monitoring memory. Finally, immutable, air-gapped backups remain immune to ransomware encryption. In this environment of asymmetric cyber warfare, these defensive layers represent the baseline requirement for institutional survival.